I'm going to start by creating a new Substance package. Here I'm going to choose the new Substance model graph, and then I'm going to link in a 3D mesh. I'll grab this leaf A and B, and we'll click open. And so here I'm going to grab these two mesh items and just drag and drop them here to my Substance graph. And here's an example of what these assets look like. Now I want to be able to switch between these two assets. So I'm going to grab here a select node, and then I'm just going to hook this into the source 0 and 1 input. And now I can actually switch between these two assets here. Okay, so first let's do a deformation. We're going to do a bend. So I'm going to grab the bend node and we'll hook this into the geometry. And now if we take a look at the bend, I can adjust my angle. However, I want this bend to actually take the size of the geometry into consideration. So to do that, I am going to grab this measure bounding box. And then here for the point max, I'm going to break this into the X, Y, and Z vectors. And then on the bend, I can use this top limit. I'm going to click this button here to expose this top limit as a pin. And then I'm just going to simply use the Y as the value input. So now the bend is actually going to work based on the size of the geometry. So now that I've done a deformation, I actually want to recompute my vertex normals. So I'm going to do that here with a mesh cleanup. And then here you can see that I can just enable the option. And we take a look. Now we have a nice smooth mesh. Okay, so the next step is I'd like to be able to scatter this leaf on a curve. So I am going to create a curve primitive node. And so here you can see we have this curve. Now I'd like to bend this node as well. So I'm going to come in here and grab a bend node. And this is going to be the geometry I want to bend. So of course here I can go in and bend this node. However, I need to also make sure that I take into consideration the size or the length of the curve. So here I can actually expose the length parameter as a value in the graph. So we'll do that. And then once again, we'll jump over to the bend. I'll create an input pin for top limit and then just plug this guy in. So now you can see the bend is indeed taking the entire length of the curve into consideration. So here I'm going to want to be able to probably expose this bend. So I'm just going to create a frame here just to give me a visual cue of that. Same thing here with the bend for my leaf. Let's create a frame here. And then also for my select, we'll just create a quick frame. So now what we're going to do is we're going to scatter the leaf on the curve. Let's go back and just set this blend here to 0. And then I am going to just simply grab a scatter on curves, and we'll go ahead and just hook this up. And if we take a look, you can see that indeed we are starting to scatter here the leaves. So we can get a better idea of what we're doing. Let's grab a merge node, and I'm going to take here my curves and then the actual curve primitive. And here you now get a more visual cue of that we are scattering that geometry here on the curve. All right, so we can go over to the curve and we can increase the actual copies amount. We can also play around with the padding because we want the leaves to grow towards the top of the stem. So what I'm going to do is just come over to the scatter curves. I'll create a little frame. This is going to be some parameters I want to tweak a little bit later on. And then also I'm going to jump over here to my curve primitive and play around with this end spin. So I'm going to set this to just a value of 3 to kind of get me going. All right, so now that I have this in place, one of the things that I want to do before the scatter on curve is I want to set just like a preliminary rotation for the mesh. So I can do that by just using a transform node here. So we'll plug in a transform. Let's jump over here to the Y rotation, and I'm just going to set this to a value of -25. And now that we have this in place, what we want to do is I want to start to work with some random values. So I'm going to grab here a jitter instances node, and let's just hook this up into my network. And we'll come over here to the jitter. Let's set a random rotation for the X. So on the minimum, I'm going to set this to -360. And then on the max, we'll set this to 360. And so now, again, we can scroll down here towards the bottom and also introduce some randomization here to our scale. So I'll set the min and max. So just a little bit of extra randomization. We can also come back to our scatter on curve and, like I said, play around with this padding. So now that we have this in place, let's now start to create the geometry for the stem. So once again, I am going to grab here a curve primitive. And this time I'm going to set the primitive type here to ellipse. Now I want to make sure that I can scale this uniformly with my length and my width. So let's expose the length as a parameter, and let's expose the width as an input pin. And then I'm just going to tie these two guys together. Now for the overall scale, let's just set this to something like, say, 0.65. This is going to be that primitive. And now I'm going to actually sweep this curve. So I'll grab the sweep curve node. And let's come over here for the curves to sweep. We'll plug this into the first input. And then let's grab our curve that represents our stem, and we'll plug this here into the curve to follow. And so here you can see that we've created that stem geometry now. So with that in place, we can actually just hook this into our merge. And if we take a look, here we have the result of our plant. Now we can just go back and start to kind of play around with some of our parameters. So for example, if we jump over here to our leaf, let's take a look at the bending of the individual leaves. So here we can just start to play around with this value. We can come back to the bend for the curve, and here we'll start to play with this. We can get a nice overall bend here. And if we like, we can also come over here to the actual select node, and then we can switch between different sources. So here you can see that we can get two different versions of this plant. Next, I'd like to take a look at how we can expose parameters. So let's take a look at the select node. And here I have my select source, which I'm using to select between the two leaf models. Now I'm going to come over here to this first button, and this is going to copy the value I have for my selected source into a new node. So I'll click the button. Here you can see that an integer is created, and now I have this node, which allows me to then, of course, switch the value that is being fed into the select node. So with this node here in my graph, I can right-click on the node and I can choose Exposed. This is going to allow me to set my ranges for this exposed parameter. So I'm going to enable a soft range and a hard range, and I want this to go from 0 to 1. And in this particular case, it's going to be the same for the hard range as well. So we'll go 0 to 1. I could write a description here. I could put this in a group. The display name, I'm just going to call it leaf selection. And that is how you can expose a parameter using the substance model graph. So I'm going to set my default value here to 1. And let's take a look at just exposing one other parameter. In this case, I'll come over here to the bend node for the leaf. So here you can see that I have this angle, and I would like to expose this as a value. So let's take a look at what range we want to do. So probably we'll set this to be, if we reset this guy 45, let's just do something like 80. So maybe we'll set this to 80. And then let's say that, our max range will be something like, I don't know, we'll say 140. So let's set this here to 80. And then I'm going to create or click on this first button, which again is going to copy this value into a new node in my graph. You can see here that we have that original value of 80 that I set as a float node. Now we can right click this node and I can choose to expose this value. So for the display name, I'm going to call it leaf bend. And then let's set our soft and hard ranges. So here for the soft range, I'm going to set this to be 80 to 140. And for the hard range, we could actually set this, let's just make this a little different. Let's just say 60 to, 160. So now we have two parameters here that have been exposed in the graph. Next, I'd like to talk about materials. So here you can see that with our select node, this is where we have our leaf, the two versions of our leaf object that we are going to switch between. So what I'm going to do now is add a material. So I will do a quick search here for set material, and then we have a node for tag material. So what we're going to do is from this select menu, I'm just going to connect in the geometry, and then for the material scene, I'm going to add in this tag material. And now I'm going to take this set material and just plug it right back into the rest of my node graph. So here with this tag material, we can come in here and give this a name. And this is going to represent the material for the leaf, meaning both objects since it's coming outside of this select node. So I'll just type in leaf here. Now you can set a color value, but at the recording of this video, this color value is not represented here in our 3D view. So I'm actually just going to leave it at this default value. But essentially what I'm doing here is just creating a material ID for the objects that I have. So that will take care of the leaf objects. Now let's also create a material for the stem. And the stem is created right here. We had that curve primitive, and then we pulled the sweep curve. This is the stem here. So once again, let's just create a material. So I will create a set material. We'll plug the geometry in, and then we will create a tag or the material ID. And for this guy here, we're just going to name it stem. And now I'll just plug this back here into that final merge node. So double click the merge. Here I can see the result of everything I'm working with here in my model graph. So let's just left click and drag, and let's just set a frame for this. And I'm just going to call this stem. So what's really cool is we can use our substance graph with our substance model graph. So here in my package, I'm going to right click and just create a new substance graph. And I'm going to call this leaf material. We'll just leave it here at this metallic roughness and click OK. So what I'm going to do here, let's go back to that substance model graph. And I'm going to pin this graph. So here in my package, you can see I have my model graph. And now I have just a traditional substance material graph. So I'll double click here. So in the material graph, let's just come over and just for demonstration purposes, let's just create just a little green color here for the plant. So maybe do something like this. And I think I will change that roughness amount slightly. Okay, so we've just made just a little bit of change to that material graph. Well, what we can do now is just simply right click here in my graph and choose View Outputs in 3D View. And here you can see that I have the two material IDs that I created for my substance model. So like I said, this is going to be the leaf material. So let's just choose leaf. And here we go. You can see we now have this leaf material. Now, again, if we zoom in, let's come back over here to that select node. Let's select my exposed parameters. So this is the leaf version B. So if we set this to the first leaf version, you can see again that material is applied. That's because we set our material after the select node. So I'll just go back and put this on my leaf version B here. So that's just a basic overview of how we can work with our substance material graph and our substance model graph here, all within the same package. So now let's talk about exporting the mesh. So you can come over to your 3D view and you can export the scene. However, we're going to export this object as a substance model. So with the substance model graph, you don't create an output node. Whatever node is selected here, this is what's going to be exported. So this is like basically the end of my modeling graph. So this is what I want to export. So now what I'll do is come over to the model graph itself and I'll right click here and choose export. Now I didn't actually name my graph, so let's just do that really quick. Let's just call this foliage, and then I will right click and then choose to export. And here you can see that it's going to export as a substance 3D model file. So I'm just going to save this guy here, and that's it. I have my substance model exported. You can import the substance models that you create in Designer into Substance Stager for rendering. So let's come over here to File and choose Import 3D Model. And I'm going to just switch my format here to Substance Models and then grab that model that I just exported from Designer. We'll click Open. And here you can see that the object has now been imported here into my scene. If we select the object and you come over here to the properties underneath the object, this is where you're going to see any exposed parameters that you create. So for example, here I have my leaf bend, and then I also have my leaf selection parameter here that I can play around with. Next, let's take a look at the material. So you'll notice here that I do have my two material IDs, but at the recording of this video, the name I set for the ID is not actually being used. So you will get the material, you just won't have the name. So I know this first material is my leaf. Let me just go ahead and just set the color value. I'm going to choose just like a green value here. And then for the actual stem, let's just use the same green. So we'll grab this guy and use the same green. With the leaf material selected, I'm also just going to quickly come down to my interior settings. I'll set my translucency here, as well as just enable my subsurface scattering. And I'll set my scattering color to be the same green. And then I can also kind of play around with the distance. So we can see what's actually happening here. Let me just enable my ray tracing, and I can use Shift and my right mouse button to rotate my light. And let's just jump over to my lights really quick, and let's just grab a new environment light. I'm just going to use that panorama. I'll use Shift and my right mouse button just to kind of rotate, get a little bit of some backlighting here. And so here we go. You can see this is the substance model just created in Substance Designer. I've now imported this into Stager, and I have all of the exposed parameters available to me that I can work with here in the properties panel for the object itself. So one last thing I want to show in this tutorial is geometry instancing. So let's take a look at how we can instance versions of this plant. So to do that, I'm going to come over here and I'm first going to create a primitive 3D. So if we double click, you can see here, this is my primitive 3D. I have a cube. For the type, I'm going to set this here to a plane. Now here in my 3D view, I'm going to set the material. Let's just use Adobe standard material for this. And I'm going to click the edit button. And this is going to let me take a look at all the properties for that material. So if I scroll down, you see I have this tessellation factor. Let's take this all the way down to 1 for just a moment, and then come over to the display and take a look at the wireframe. So this is that primitive 3D object that I just created. If I increase the tessellation, you can see here that I'm increasing the vertex count. You can keep an eye on the vertex count in your scene by also coming down to the display and taking a look at scene stats. And here you'll get a lot of information about the models that you're creating. So I'm going to just turn that off for now. And I'll also turn off my wireframe. So let's just keep that tessellation factor at 6. So we have our plane. The next thing I'm going to do is use a mesh sampler. So we're going to sample the mesh, and you can see that this is just going to give me a series of points based on the vertices of the sampled mesh. And that is also driven here by this sample count. So let's just keep this at maybe a value of 77. So now I have these points. Now let's grab the geometry instancing node. So here you can see that it's asking for a point set as input, and we have one thanks to our mesh sampler. So we'll include that point set. And for the actual asset itself, let's just move this node here. Actually, let's just group all of these guys here after my final merge. So if we take a look, this is the merge where we have our plant, and that is going to be the asset or scene. So we'll plug this guy in, double click the geometry instance node, and now you can see that I'm instancing that plant. Now, one issue with this, if we zoom in, you'll notice that, well, it's instancing, I have the stem object, but then I also have just some object that is just my leaf. And that's because this merge node, you can see here, it has this group name parameter. The merge node, by default, you can think of it like a collection of assets, which in our case, it is. It's basically a collection of a leaf and a stem asset. However, if we set this as a group, so for example, let's say I call this plant, what it's going to do now is treat both of the objects or any objects you have coming into the merge as a single grouped set of objects. So now when we come back to our geometry instance node, it's now instancing that entire group instead of each individual asset that is in that merge node. And this is more of what we want. So with this in place, what we can do now is start to add some randomness. So here I'm going to grab jitter instances, and we'll plug this in. And in this instance node, let's just start here at the bottom, and let's introduce some randomization to the overall scale. So we'll set this kind of low, and maybe you can make this one a little bit higher. So we'll do something like this here. And so we have a little bit of randomization there. Let's also come over to the rotation on the y-axis, and let's just set this to a minimum of -360 and a maximum of 360. So here, again, we're getting just a little bit more variation here. And let's also just kind of play around slightly with the Z. So I'll just change this a little bit, something like that. And here you go. So you can see that, we can quickly instance these objects. Also, at any time, we can just go back through our node. So for example, if I want to just come over here to my bend node and start to play around here with this, let's just grab my exposed parameter. I can actually bend the leaves here. So again, you have access to all of the controls as you work here through the node graph, very similar to how you're used to working with Substance material graphs. Go back and let's just change our leaf selection, get a different type of plant here, and so on. So as you work, you're definitely going to want to keep an eye on your display scene stats. You can see here that I have a huge amount of triangles in this scene. So the more geometry you have, the less performant the scene is going to be. So you want to just keep an eye out on how things are tessellated. Just to give you an idea on how you can kind of look to optimize parts of this. So let's just zoom in where we have basically our stem, and we'll come over here to basically our sweep curve. So for example, you can see here that, well, we have our sweep curve, but if we look at the curve primitive itself, it's going to have a tessellation amount here. So at this state, or at this level, we have 192 triangles, but notice as I drop this tessellation down, you're going to start to actually decrease the vertice and triangle count. So, again, that can help as you're starting to like create copies and copies of this object. But again, I'm bending this, so I want to make sure that I have enough tessellation to accommodate the bend deformation, but then not too much that my entire scene slows down. So in this scene, the real culprit is going to come down to these objects that I have. So you can see here, this single leaf geometry already has 800 triangles. So as I start to scatter this object, the triangle count's just going to increase exponentially. So you just want to make sure you have your tessellation set so you get good enough quality, but you also have good performance. It's very much like optimizing your substance material graphs in terms of node compute time. So here we can look at a more complex example that was created by Celine. Here you can see that I have my 3D view and my 3D graph, as well as my traditional substance material graph here and my 2D view towards the bottom. So now I'll jump over to the 3D graph and I'm just going to play around with some of the exposed parameters. So for example, I'm going to increase the lantern amount. And next, I'll come over and adjust the wind control settings. And because we can actually create our substance material graphs and apply those to the 3D mesh, I can quickly jump over to my 2D graph and then start to play with any of the exposed values that I have there, such as the hue and saturation. It's pretty amazing to be able to work with your 3D scene and the model graph as well as your substance material graph here at the same time. Next, we have a tower created in Designer. This model was created by Luke, and there are various exposed parameters that can change the look of the mesh. You can build complex interactions between objects. You can see that changing the position and rotation of the chimney also affects the tiles on the roof. The tiles are removed as the chimney position is updated. Taking a kit bash-like approach, here the chimney is swapped out for a different version. Next, let's remove some of the roof tiles and take a look at a rendering of this asset using iRay in Substance Designer. You now have the capability to create procedural meshes as well as materials, and as we showcase, you can leverage the power of procedural materials with your mesh creations.